The destructive beauty of tornadoes in and of itself is enough to captivate, compel, and strike fear into the hearts of those who get too close. But sometimes the cloudy funnels that amaze people worldwide can go a step further. Sometimes, tornadoes produce phenomena that just flat out shouldn't be able to happen. Satellite tornadoes, twin tornadoes, tornado vortex mergers, helical vortices, and the infamous dead man walking are all examples of scenarios where tornadoes truly bend the boundaries of the possible. And today, we're going to be taking a look at the top 9 rarest tornado phenomena ever caught on camera, starting with multi-vortex tornadoes. Even the most basic of tornadoes can take an otherwise pleasant day and turn it into a life-changing nightmare for anyone involved. But what happens when a tornado spins up mini tornadoes inside of itself? A tornado with multiple engines all firing in sync. This is a multi-vortex tornado. Here's what most people are unaware of. In special circumstances, multiple sub-vortices can exist simultaneously inside one circulation, creating a rotating column of destruction that spins like the chamber of a revolver ready to fire. And this effect isn't just visual. It can add up to 100 miles per hour of ground relative wind speed to an already devastating tornado. Because when the winds of the sub-vortices align with the already powerful rotation of the storm, the wind effect compounds and massively increases its destructive power. The winds in a multi-vortex tornado are so powerful that a spiral-shaped scar can be seen left in the ground. Scientists call this cycloidal ground scouring, and it's hard proof that the tornado was violent enough to rip the surface of the ground away from the earth itself, and why persistent multi-vortex tornadoes are not only rare, but even more deadly. Most of the time, multi-vortex tornadoes stabilize into one main vortex within at most a minute. But tornadoes like the one on screen are proof that some storms are dead set on maximizing its destructive power. Number 8. Horizontal vortices. Most of the time, the rotation of a tornado comes from its parent supercell. But sometimes, the air near the ground starts rolling sideways instead of upward, forming long, low tubes of rotating motion that slide across the surface. Most of the time, they go completely unnoticed, because there's nothing to make them visible. But when dust or debris gets pulled into them, you can suddenly watch rotation moving sideways across the landscape. And when an already violent tornado pulls these vortices inward, it can look like an Everest-sized monster come to life, reaching out to claim its next target. Number 7. Anticyclonic tornadoes. More than 98% of all tornadoes rotate cyclonically, or counterclockwise. And this isn't a coincidence. It's a direct result of how rotating storms form in the first place. Because large thunderstorms almost always inherit their rotation from the broader atmosphere. Wind shear creates horizontal rotation in the air that gets tilted upright inside a storm cell. That tilted rotation becomes the mesocyclone, creating a cyclonically rotating supercell capable of producing tornadoes. But sometimes that rule breaks, and a tornado forms that spins in the opposite direction. At first glance, it just looks wrong, like the footage is mirrored or reversed. The debris moves the wrong way, the inflow curves in the opposite direction, and even experienced storm chasers often don't realize what they're looking at first. In some cases, rare anticyclonic supercells can spawn these mirrored funnels that look like they're straight out of an episode of Black Mirror. But many anticyclonic tornadoes inherit its rotation from localized pockets of vortice inside a cyclonically rotating supercell, resulting in something deeply unnatural. A tornado spinning against the flow of the storm that created it. So when anticyclonic tornadoes are captured clearly, they're more than just unusual footage. They're one of the few moments where a tornado openly violates the fundamental pattern that almost all tornadoes follow. Number 6. Satellite tornadoes. Once you accept that a storm can generate more than one source of rotation, something even stranger becomes possible. The same supercell can produce a second tornado that pairs almost symbiotically with the first. Because a large tornado doesn't just rotate air inside of itself, it reshapes the airflow around it, creating strong wind shear and secondary pockets of rotation in the surrounding atmosphere. In rare cases, one of those pockets can become so strong it forms its own tornado. And once that happens, the larger circulation can trap the smaller one inside its broader field, forcing it to move in a curved path around the main funnel. Like a moon caught in the gravity of its parent planet. But it's not gravity that's causing the orbit. It's the fierce wind of the dominant tornado, rotating so strongly it forces the satellite to move against its own will. Most satellites don't last long, because the surrounding flow simply can't support both systems long term. But when they're captured clearly, they reveal something important. A tornado isn't just a single object. It's a system, with winds so strong it's capable of summoning miniature versions of itself to aid in the devastation. Number 5. Twin tornadoes. Satellite tornadoes feel strange because one circulation dominates the other. But sometimes that hierarchy never forms. Instead of a parent tornado forming with a smaller one trapped inside its flow, a storm can produce 2 alpha tornadoes at the same time, both from the same supercell, creating a violent battle for dominance. This is what's known as twin tornadoes. Neither tornado is being carried by the other, and they aren't embedded in the same circulation. They each have their own inflow, their own pressure core, and their own connection to the ground. At first glance, it looks similar to a satellite setup, but the dynamics are completely different and far less stable. Because in most twin tornado setups, both tornadoes rotate cyclonically. That means the winds between them are being pulled inward towards both cores at once, while simultaneously clashing against each other, creating a system that seems like it should cancel itself out. But in reality, it just becomes violently unstable. The atmosphere almost never allows this to persist. That's why there are so few documented examples, and in even rarer cases, the storm doesn't choose which one survives. It lets them collide. Number 4. Tornado vortex mergers. Most of the time, when 2 tornadoes get too close to each other, one of them simply doesn't survive the encounter. In almost every case, when 2 tornadoes close in on each other, it ends with one weakening and disappearing, while the other continues on. But under very specific, extremely rare conditions, the 2 pressure cores don't destroy each other. They join forces. And when that happens, the funnels deform, tighten, and reorganize into one single circulation with one unified core where there used to be 2. Understand this. Storms almost never allow this to happen. The system almost always chooses collapse instead of combination, which is why true vortex mergers are so rare and difficult to document on video. And when it does happen, it's one of the few times you can watch 2 tornadoes call a truce on their battle for dominance and agree to join forces together. And frankly, it's hard to say which outcome is more unsettling. Number 3. Dead man walking. If you thought horizontal vortices made tornadoes look like real-life monsters, just wait until you see the dead man walking. A vortex structure that turns already frightening tornadoes into an eerily human-like walking catastrophe. So, what's actually happening here? Dead man walking tornadoes, if broken down to their simplest definition, are simply multi-vortex tornadoes that happen to arrange themselves temporarily into a human form. Instead of dozens of small subvortices circling the main rotation like the chamber of a revolver, the flow organizes into just a few dominant vortices. And it's so incredibly rare because the visual conditions almost never line up. So when a dead man walking tornado is captured clearly, it's not just a strange shape. It's a moment where the internal chaos of a violent system briefly organizes into something the human eye can recognize as a stampeding wind giant marching towards its next target. Number 2. Helical tornadoes. The vast majority of tornadoes appear as stable, vertical columns rotating around a single axis. But in extraordinarily rare cases, that alignment breaks, and the entire tornado begins to twist into a corkscrew shape as the core of the vortex bends and coils in an unsettling display of organized chaos. And it's all due to something scientists call a vortex breakdown bubble. Because sometimes, the smooth upward spiral of a tornado briefly slows down, or even reverses in a small region inside the core. When that happens, a bubble of downward moving air forces the core of the tornado to bend around it. The result is a tornado that twists into a spiral instead of staying upright. What you're seeing now isn't the tornado falling apart. It's the actual internal structure of the tornado physically deforming in real time. And sometimes the tornado can grow even stronger while this is happening. Only a tiny fraction of tornadoes ever reveal a helical vortex. And if you're ever lucky enough to see one, you're even luckier to be far enough away that its destructive power is out of reach. Number 1. Interior Vortices. The Clear Lake, South Dakota tornado of 2025 became one of the most viral storms of the decade.
Oh my god. What is that? What the heck is that? I've never seen that before.
As the wide outer funnel slowly lifted and faded, a thin, snaking column remained behind. A serpentine structure, rising from the ground, bending and slithering upward through the center of the larger funnel like a semi-liquid slinky. Within hours, the internet had a name for it: the interior vortex. But that label isn't quite right, because there's no scientific data that even closely illustrates a phenomenon that fits this label. So what really happened? Because if you look at this footage, it sure looks like some sort of internal vortex. To understand what's happening here, we first need to understand this core concept. Tornadoes are not static events. The visible funnel of a tornado is a dynamically changing system where pressure, temperature, and moisture line up in a way that allows condensation to form. That's why tornadoes often widen and narrow over the course of their lives. And what we're looking at is the most extreme example. We can know this for certain by looking at just a few frames of footage. Notice how the snake-like structure isn't actually inside the larger funnel as it twirls up from the ground. What you're looking at is a tornado dynamically reorganizing in real time. The velocity core is tightening, the area of low pressure and condensation is constricting, and the now rope tornado has become dynamically unstable, unbound by the organized structure that can be seen dissipating in real time. This is what a tornado looks like when it reorganizes and destabilizes before our eyes. We just almost never get to see it happen this clearly.